Hello everyone, my name is Elsa Alvarez, and I'll be your teacher today as we explore the fascinating world of triple integral. In this video, we're going to break down the concept, discuss example, and solve exercises together. This is the fourth example in a series that my groupmates and I have been working on, and I'm excited to share it with you guys. So grab your notebook and pen because we're about to embark on an exciting journey of triple integral. Are you ready? Let's get started. So for our fourth examples, we're going to use a triple integral to determine the volume of the region that is below z is equals to 8 minus x squared minus y squared above z is equals to the negative of the square root of 4x squared plus 4y squared, and inside x squared plus y squared is equals to 4. Alright, let's begin with a brief outline of the area for which we need the volume. This will help us understand what we're working with. We'll refer to make to this area as E. So, so we also have a sketch that includes both a traditional set of axes and a set of box axes. This will assist us in visualizing the surface within the region. The top of the region, or the orange colored in the surface, is the portion of the graph of the elliptic paraboloid z is equals to 8 minus x squared minus y squared that is inside the cylinder. X squared plus y squared is equals to 4. The bottom of the region is the portion of the graph of the cone z is equals to the negative of the square root of 4x squared plus 4y squared that is inside the cylinder. X squared plus y squared is equals to 4. The walls of the region, which are translucent to show the bottom portion, is the cylinder. X squared plus y squared is equals to 4. So the volume of this solid is given by the volume is equals to the integral of dv. So the next step is to establish the limit for the integral. From the sketch we made, it's clear that we'll need to integrate with respect to z. Here are those limits. So we have the negative of the square root of 4x squared plus 4y squared is less than or equal to z, and z is less than or equal to 8 minus x squared minus y squared. We also needs limit for d. In this case, d is just the d's given by x squared plus y squared less than or equal to 4. The portion of the xy plane that we need to graph the paraboloid and cone and so is d. Since d is a disk, it would be logical to use polar coordinates for integration over it. Here are the limits for d. So we have 0 less than or equal to theta, and theta is less than or equal to 2 theta. 2 pi rather. 0 is less than or equal to r, and r is less than or equal to 2. Now let's set up the volume integral as follow. V, or volume, is equals to the integral of E, or E is our area. dV is equals to D, or our disk. The integral of negative the integral of negative of the square root of 4x squared plus 4y squared to 8 minus x squared minus y squared with respect to z. Knowing that we'll need to perform the outer double integral in polar coordinates, we'll hold of putting those limits until we've completed the z integration. Okay, let's do it. Do the z integration. So we have the v, or volume, is equals to the integral of z, the negative, the square root of 4x squared plus 4y squared to 8 minus z squared minus y squared with respect to a is equals to the integral of 8 minus x squared minus y squared plus the square root of 4x squared plus 4y squared dA. Now let's convert the integration over the polar coordinates. Don't forget that 2x squared plus 4y squared. Don't forget that x squared plus y squared is equals to r squared, and that dA is equals to r dr d theta. So the volume integral in terms of polar coordinates is then. So the volume integral in terms of polar coordinate is then b is equals to the integral of 0 to 2 theta with respect to d theta, and the integral of 0 to 2 with respect to r. We have 8 minus r squared plus 2r with respect to r. So we have the v, or volume, is equals to the integral of 0 to 2 pi with respect to d theta, and the integral of 0 to 2 with respect to r, and 8 minus r cubed plus 2 r squared. So integration is done. So you have the volume is equals to the integral of 0 to 2 pi 4 r squared minus 1/4 r raised to 4 plus 2/3 r cubed, where 0 to 2, and d theta is equals to the integral of 0 to 2x 52 over 3 theta d theta. Finally, we can compute the very simple theta integral to get the volume of the region. So we have the volume, or v, is equals to the integral of 0 to 2 pi 52 over 3 d theta is equals to 104 over 3. So now we have an exercises. So this is number 5 in our Let's Do It workbook. So in number 5, we have the integral of 0 to 2 with respect to x, and the integral of negative 1 to x squared with respect to I, and we have the integral of 1 to y with respect to z, and we have x, y, and z. So to solve this first, we're going to get the center. So the center of this problem is the integral of 1 to y with respect to z, x, y, z. So first is you're going to write the integral of 0 to 2 with respect to x, and the integral of negative 1 to x squared with respect to y. So we have the summation of xy times the integral of z. The integral of z is z squared over 2 with respect to 1 to y. So next is we're going to multiply the xy to the integration of z. So we have the equals the integral of 0 to 2 with respect to x, and we have the integral of negative 1 x squared with respect to y. So we have xyz squared over 2 with respect to 1 2y. So next is we're going to distribute our value of our z. So we have a y 1 to y. So we have equals to the integral of 0 to with respect to x, and the integral of negative 1 to x squared with respect to y. So we have the summation of xy times y squared. So um, we're going to put the value of z. So we have a y, so that's why y squared over 2 minus x y times 1, since our z is 1. So 1 raised to 2 or squared over 2. So next is we're going to subtract these two fraction. So we have the integral of 0 to 2 with respect to x, and the integral of negative 1 to x squared with respect to y. So we have the summation of xy times y squared minus 1 over 2. So next is we have the integral of 0 to 2. So we have x times negative 2x raised to the power of 4 plus x raised to the power of 8 plus x over 8 with respect to x. So if we put it here on the calculator, or we're going to compute the value of x, so we get the answer 623 over 60. So since this answer cannot be simplified, so this is the final answer. So for our next problem, we have the number 6 in our let's do it and our workbook part. So we have the integral of 0 to 1 with respect to x, and the integral of 0 to x with respect to y, and the integral of 0 to x plus y with respect to z. So we have 2x plus y minus 1. So the first solution, we're just copying the problem. So same lang. And next is we're going to get the center of this problem. So we have the integral of 0 to x plus y to x plus y minus 1. So this is with respect to z. So we're just going to integrate. So we have the integral of 0 to 1 with respect to x, and the integral of 0 to x with respect to y. So we have the 2x z plus yz minus z with respect to 0 to x plus y. So next is we're going to distribute the integral or the value of z. So we're just going to distribute the value of z. So we have 2x, and z is we're going to change the z to x plus y times x plus y minus x plus y. So minus 0. So any number that multiply or add 0 is still the same. So next is we're going to multiply 2x to x plus y here. So the next problem, we have an integral of 0 to 1 and the integral of 0 to x. So we're just going to multiply the 2x. So we have a 2x squared. So this is a 2xy, and this is y we're just going to add. So we have a 2xy and xy is 3y. Next is just going to uh, change the sign since this is negative. So we're just going to multiply negative x. So we have here, and negative times y. So we have negative y. So this is respect to x and y. So this is the value of c. So next is going to have an integral of 0 to 1 with respect to x. So now we're going to integrate the value of y. So now we have copy the 2x squared, and so we're going to put y here. Next is to plus and integrate the value of y. So y squared integrate is y cubed over 3 plus 3x, and the value of y. So we're going to integrate y. So we have y squared over 2 minus xy minus same here. I'm going to integrate. So we have y squared over 2 with respect to 0 to x. Next is we're going to multiply. So we have the integral of 0 to 1 with respect to x. So we have a 23 over 6 and x cubed minus 3 over 2 x squared dx. So next is we're going to integrate the value of x. So we have the summation of 23 over 6 times the integral of x cubed. We have x raised to the power of 4 over 4 minus 3 halves times the integration of x squared. So we have x cubed over 3 with respect to 0 to 1. So next is we're going to distribute the 0 and 1. So distribute the value of x here. So at first we're going to multiply the denominator. So we have 6 times 4, we have 24. So 23 over 24. So times 1. Okay, we're going to put the 1 here. Next is the 0. So negative 1 half, and because 1 half because 2 times 3 is 6, and 6. So we can simplify 3 over 6 to 1 half. So we have 1 raised to the power of 3 minus 0. So if we compute it all, so this problem will result 11 over 24. So next is the item number 8 in our let's do it in our workbook part. So we have an integral of 0 to 1 with respect to x, and the integral of negative 1 to 2 with respect to y, and the integral of 0 to 3 with respect to z. So you have the value here is x, y, and z squared. So next is we're going to get as usual, we're going to get the center of this problem. So we're going to get the integral of z. So we have an integral of 0 to 1 with respect to x, and the integral of negative 1 to 2 with respect to y. So with the summation of 1/3 xy z cubed with respect to 0 to 3. So this is the same as before. So this is z cubed over 3. So the integral of z squared, but I put it here to direct or to see the number 1 over third. So next is we're going to put 1/3 here in front. So we have 1/3 integral of 0 to 1 with respect to x, and integral of -1 to 2 with respect to y. So we're going to distribute the value of z. So we have a 0 and the value of 3. So xy, we're going to change the z to 3. So we have 3 raised to the power of 3 minus 0. So next is we're just going to copy the 1/3, and we have the integral of 0 to 1 with respect to x, and the integral of -1 to 2 with respect to y. So the value of our z now is 27, because 27 raised to the power of 3, so that is 3 times 3 times 3. So we come up the number 27xy. Next is we're going to divide the or multiply the 1/3 to 27. So next is we have an integral of 0 to 1 with respect to x, and the integral of -1 to 2 with respect to y. So we're just going to multiply 1/3 times 27. So we have the value of our z here is 9xy. Next is the value of our y. We're going to integrate the value of our y. So we have the number here 9, so we're going to put here in front. So we have 9, the integral of 0 to 1. So the summation of 1/2, because the here same here and our z. So we're going to put here 1/3. So we have x y squared with respect to -1 to 2. Next is same here in our value of our z. So we're just going to multiply the 9 and 1/2. So we have 9 over 2. So we have the integral of 0 to 1. Next is we're going to distribute the value of our y. So we're just going to change the value of our y. So here is -1 and here is positive 2. So x times 2 raised to the power of 2 minus x times the -1 raised to the power of 2. So now is we're just going